about special right triangles, but one in particular, the right isosceles triangle. So the right isosceles, so it's right triangle because I have a 90-degree angle right there, and it's isosceles because these two legs are congruent. And by definition, if the two legs are congruent, these two angles are also congruent. Now the ratios are, I don't know what the length of the legs are, but I do know they're congruent. So if I'm looking at this angle right here, this side right there is x. When I'm looking at this angle right here, the other 45 degrees, this leg right there is x. Okay? Do I need to go over why these two angles are 45? No. Okay. I know that 90 plus 45 plus 45 is 180. Now, when I'm looking over here at the 90-degree angle, my yellow marker right there, I like to highlight the hypotenuse so everybody knows where that is. So it's always across from the 90-degree angle. And that ratio right there is whatever the length of the leg is times square root of 2. So right there across from 90 degrees, we have x square root of 2. So these are the ratios for the right isosceles triangle. And every time we're going to solve a triangle, or we're going to use the special rights, the 45, 45, 90 in particular, we're going to use the ratio. And you're going to do so much of this that you're going to end up memorizing it. So before you even start, that's how you're going to start. Before you even look at the question. Well, first you need to identify if it's a 45, 45, 90. And in this case, I know because these two angles are congruent, that means these two legs are congruent. Okay, right there across from the 90-degree angle, I have the hypotenuse right there highlighted in yellow. And the hypotenuse right there across from 90 degrees, I have 7 square root of 2. Now I need to find A. What does that mean? I don't have A anywhere. But be careful that it's a lowercase a. Here I have capital A. Okay, the way you label the sides, if the angle A is right here, the side A is directly across from that angle A. So we're looking for that length right there. All right, so if the hypotenuse right there across from 90 degrees is x square root of 2, and that x square root of 2 equals 7 square root of 2, we're going to solve for x. So you divide both sides by square root of 2. Square root of 2 divided by square root of 2 is 1. Square root of 2 divided by square root of 2 is 1. That means x is 7. Okay, so 7 is x. I can just simply substitute that 7 right there for x. Voila. And if x is 7, it's directly across from the 45-degree angle. That means A is 7. Like I said, so this is a right isosceles triangle. That means these two legs are congruent. So I start out by writing out my rates. So x, 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 square root of 2. I know that directly across from 45 degrees, I have square root of 3. It doesn't matter which one you choose because they're the same. So I know x equals square root of 3. But the question is asking, find the length of AB. So AB is right there, the hypotenuse. Okay, so in the length of AB is directly across from the 90-degree angle. So we're looking for this guy right here. I already know x is square root of 3. So you have to go ahead and substitute the value for x right there. So the length of AB is whatever x is times square root of 2. And I know x is square root of 3. Okay, now you just multiply. Square root of 3 times square root of 2, we get square root of 6. And that's all there is to it. I have one more question. So this one, this is also a 45, 45, 90. And I know that because these two legs are congruent. So this is the hypotenuse, directly across on the 90. So we need to find B, or lowercase b, which is directly across from angle B. So we're looking for this one right there. Okay, and this one is directly across from 45. Oh, let's write the ratios. X, square root of 2. Okay, so we're looking for B right there. And CB will also be directly across from 45. So as soon as I find B, I know B and CB are congruent. Okay, so I know as soon as I find B, I already have CB right there. Okay, so right across from 90 degrees, I have 3 square root of 15. I know x square root of 2 equals 3 square root of 15. Like we did in example 2, we need to divide both sides by square root of 2. This would be great, but I cannot leave the square root in the denominator. So we have to rationalize the denominator by multiplying numerator and denominator by square root of 2. So 3 remains there. Now you multiply 15, square root of 15 times square root of 2. You get square root of 30. Now here you have square root of 2 times square root of 2. You get square root of 4. Well, square root of 4, that's a perfect square, so I would just simplify that. So 3, can I simplify square root of 30? No, I can't. So you leave that under the root, and then you take the square root of 4, you get 2. All this work to find x. And x is right there directly across from 45 degrees, and that x is b. So 3 square root of 30 over 2. So b is 3 square root of 30 over 2. And also CB, because we decided early on that this side right there, or this leg, is congruent to this leg by definition of the right isosceles triangle. So 3 square root of 30 over 2. I'll see you next time.